Hi everyone, Victor here, and today we'll have another look at the inspector from SICK, and we'll talk about a detailed inspection called pattern. To show you what this pattern tool can do, we'll look at two different examples.
To get things started, we have already set up the SOPA software and created a reference object. We'll be looking at this SICK logo, and we have prepared an object locator that finds the rectangle surrounding it. Now, let's say we have an application where we want to make sure that this logo looks exactly the same for a large number of samples. This is a perfect task for the pattern tool. The pattern tool compares a grayscale pattern in the camera's view with the corresponding pattern in the reference image. It then tells us how good these two images match each other. We'll add an inspection by clicking the pattern icon and placing the region, which is represented by a yellow box, over the area that we want to inspect. Also, always make sure to give your inspections meaningful names. It will make your job easier later on. When we've added an inspection, we can see that the pattern tool has two parameters to adjust. We can set the position tolerance from 0 to 4 pixels. This tolerance specifies the maximum positional offset allowed between the patterns. If there is an object locator present, like in this case, the object locator is the point of reference for the positional offset. The other parameter is the match threshold. This setting simply specifies how similar the live image must be to our reference image for the inspection to pass. Typical values for this setting are between 80 and 95%. When we go to the live image, we can keep an eye on the meter in the match setting slider. This meter represents the match value that the camera is currently giving us, and we can use it for easily adjusting the threshold in real time by comparing correct samples with incorrect ones. It is green when the value is above the threshold and turns red if the value dips below it. Now we have specified the working area for the inspection as well as an initial threshold value, so let's see what it can do. The inspection fails if the logo has parts missing, as we can see here. Even smaller defects, like this one, can be detected. We'll just have to move the threshold a little higher until we are certain to detect even this small error. In a situation where the errors might be very small and it's hard to find a good threshold, it is often a good idea to split the inspection into several smaller ones. In a smaller region, an error will have a bigger impact on the match value. Unlike the pixel counter tool, which counts pixels within a certain intensity range, the pattern tool can detect defects like these, where the number of dark pixels might be correct, but the logo still is incorrectly printed. Note that the pattern tool can match patterns in images where the overall intensity is uniformly changed, but not in images where the intensities are inverted. To show another example of where the pattern tool can be used to find defects, we'll take a look at this reference image of a keyboard's numpad. We'll use it to be able to detect if the buttons are mounted correctly. If we look at this one, where we've let the number 1 and the number 7 change place, we can see that the pattern tool can tell us that something is wrong even if the difference is small.
And that concludes this video about the pattern tool. Thanks for watching.
Of small details. It's robust on intensity variations and it ensures a high quality throughput. For more information, visit www.sick.com.